Now we'll discuss about chemical reaction of compounds of carbon. So question number 1 is, how many types of monohalo product can be formed by halogenation of propane? Now you can see the structure of propane. There are two types of carbon. Two terminal carbons are of primary. The middle carbon is of secondary. Now we substitute the hydrogen with halogen in the presence of sunlight. There is possibility to remove hydrogen from the terminal carbon. Then this monohalo product will be formed. Another possibility is that you can remove the hydrogen from secondary carbon. So this will be another product. So we can see there is one chloropropane and two chloropropane. So there two compounds can be formed by monohalogenation of propane. Next question. An alkane of molecular weight 72 gives only one type of monohalo product. Now deduce the structure of alkane. Now you are given molecular weight 72 and the category is alkane. General formula for alkane is CN H twice and plus 2. Now we know the atomic weight of carbon is 12. Atomic weight of hydrogen is 1. Total weight is 72. So when we solve this, N comes to 5. That is, there are 5 carbon in that given alkane. Now it is given that only one type of monohalo product is formed by the halogenation of that alkane. So we have to reduce the structure. So we can see that all carbons are of only one type, that is 2,2-dimethylpropane. Now you can see there are 5 carbon atoms, out of 4 are of 1 degree type. In the middle carbon, which is quaternary, it doesn't have any hydrogen. So hydrogen will remove from these 4 terminal carbons. So there will be only one type of monohalo product. Next question. Which type of mechanism is followed in halogenation of alkane in presence of sunlight? This is free radical mechanism. This involves 3 types of steps. First one is chain initiation. Second is chain propagation. And third one is chain termination. In this section, many free radicals are formed, in which halo free radicals, methyl free radicals are obtained. Next question. Arrange the halogens in increasing order of reactivity towards alkanes. Answer is chlorine is most reactive, then chlorine, then bromine, and iodine. For fluorine, it is highly vigorous reaction, and iodine is somewhat reversible reaction. Complete the following reaction. First reaction is CH3 CH double bond plus HBr. Second reaction CH3 CH2 CH double bond CH2 plus HBr in presence of H2O2. Third reaction is CH3 CH2 CH3 double bond CH2 plus HCl. These three reactions are of addition types, that is, we have to add a compound on the multiple bond. In the reaction A, there is addition of HBr, and this type of reaction also known as hydrohalogenation. So here you can see in CH3CH2, this is asymmetrical alkene. For this type of addition, the negative part of the reagent, that is bromine, will goes to the carbon which have number of hydrogen less. So here we can see there are two carbons which are bonded together with double bond. This carbon have number of hydrogen 1 and this carbon have a number of hydrogen 2. So negative part of this reagent, that is bromide, will goes to this carbon and the hydrogen will goes to this carbon. So finally product will be CH3 CHBr CH3, and this type of addition is known as Markovnikov addition. In reaction B, CH3 CH2 CH double bond CH2. This is also an asymmetrical alkene. So according to Markovnikov rule, product should be this CH3 CH2 CHBr CH3. But this is not the actual compound. Actual product of this reaction is CH3 CH2 CH2 CH2Br. This is the actual product, because here we have used hydrogen peroxide. Then the hydrogen peroxide product will change and addition will be anti-Markovnikov. Next equation, CH3CH2 C double bond CH2 CH3 plus HCl. Here you can see there is no hydrogen peroxide. Alkene is also asymmetrical, so this carbon have low number of hydrogen, so addition of chloride will goes to this carbon. Final product is CH3 CH2 Cl CH3. Next question, from oxidation reduction, complete the following reaction. First reaction is CH3 CH2 OH in the presence of acidic K2Cr2O7. Next equation, CH3 CHOH CH3, reagent is same, H plus and K2Cr2O7. In reaction A, K2Cr2O7 is used, which is a very good oxidizing agent. So alcohol is converted into first aldehyde, then an acid. In case of secondary alcohol, this part of compound will oxidize to form ketone. On further oxidation is also given same acid, CH3 CH2CO. Next question, complete this reaction, CH3 CH2 CH2OH. You can see this is combustion reaction. Product will be carbon dioxide and water with the liberation of some energy, because reaction is exothermic reaction. What is esterification in hydrolysis reaction? First of all, is the esterification. In this type of reaction, an ester, when reacted with an acid, carboxylic acid, in the presence of a small amount of sulfuric acid, it will give a fruity smell. ये भी इस step को delete करना क्या है? For esterification, we require carboxylic acid and an alcohol in the presence of some acid. There will be removal of H2O and formation of a compound which gives a fruity smell is known as ester, and this reaction is known as esterification. Now, this reverse of this reaction, that is formation of carboxylic acid and alcohol by using acid or base, is known as hydrolysis reaction. Next question is, what is salting out? In saponification, when we form soap, generally this reaction is followed. Triglycerides of long chain fatty acid, when reacted with sodium hydroxide in presence of some heat, it gives soap, glycerol also. Now this mixture is completely soluble. To separate this part of the solution, that is soap, we have to add some NaCl. So due to this sodium ion, that is common ion effect, RCO minus Na plus is separated from the solution. This effect is known as salting out.